Thank you. Okay, I think we're still on. Good morning, everybody. As Petrus has mentioned, title of my talk, but my presentation, I'd like to first say that due to I was unable to get a lot of access to the biodiversity data, so I'll be only talking about for the consequences for the fire regimes between the two parks. I'd like to acknowledge my collaborators, Antonia Akbra from the Limpopo National Park, Natasha from the University of Eduardo Milan, and then Gernot from Zeabris Consultant Agency. We do know that fires are an important disturbance where more than 40% of the world terrestrial systems are affected by fires. And the vegetation in these landscapes are not only survive fire, but do promote fire. But this talk, I'll be concentrating on the effect of fires in savannah ecosystems and specifically two conservation agencies that make up part of the Greater Limpopo Transfrontier Park. It's really important to note that fires in savannah ecosystems are extremely important in that we are now coming up and facing with things or phrases such as the death of savannas. We are losing this ecosystem to inappropriate fire regimes. The Greater Limpopo Transfrontier Park was established in 2002, where 3 countries then signed an agreement to form this area made up of South Africa, the Kruger National Park, Mozambique, the Limpopo National Park, and Gonorrhoeau in Zimbabwe. I will be focusing my analysis and the discussions for this talk in the Kruger National Park and the Limpopo National Park, but specifically north of the Olifants River within the Kruger National Park. Some of the data will be presented. We'll be breaking up into the 2 dominant soil types in the Kruger National Park, our granites and basalt. And Limpopo National Park, the wardens and the managers there felt that they needed 3 soil types, so we'll be looking at the Wambia sandfelt, this greenish bit, which is the Mopani on shrubfelt on calcrete, and then the Limbombo North soil type in the Limpopo National Park. What's very interesting and why we really took on this study is that if you look at this conservation area, there are 2 very different fire management strategies that have evolved over the decades. Specifically for the Kruger National Park, I can say it's a very command and controlled fire implementation for the park. We have a very well-structured fire management plan. We also have a very long history of fire research that have influenced the changes that have come across in our implementing our various fire policy in the Kruger National Park, where we have the long-term burning experiment that was set up in the 1950s, and that really, data from there has influenced the way we manage fires in the park currently. Another important fact to take note, we have a limited number of people living in the park, and we use fire as an ecological tool. Whereas on the other side, you have the extreme case where the Limpopo National Park, I would say it's a very unstructured, hands-off approach, laissez-faire. The fire managers will tell you if a fire burns, they let it burn. Resources are limited, so they do not have the capabilities at the moment to go and either suppress fires, put in fires if need be. Fire research is in infancy in the park, we'll say less than 5 years. This project is the core of the fire research that's taking place there. Very important, there's still in the Limpopo National Park 7,500 people living in the core area, where the buffer zone, you can say there's almost 20,000 people that still impact in the park. So therefore, fire in the Limpopo National Park is not only used as an ecological tool, but sustains people's livelihoods. And we need to take that into consideration when developing a fire management plan for the area. The overall project, the objectives for the project were to, first of all, characterize the fire regime for the 2 different parks, and then we want to determine what was the consequences of these fire regimes on biodiversity, vegetation and fauna. Vegetation, we looked at the woody and the grass component. Our fauna, we stuck to small mammals and also some reptile traps that we put out. In the Limpopo National Park, we ran structured community interviews to look at fire the effects of fire on the resource utilization in the area, specifically with Mopani worms, fuel for wood harvesting and medicinal plants. Then the other objective for this project was to actually provide an operational fire management strategy for Limpopo National Park, because it is non-existent at the moment. And then to look at what the consequences of these, the data that we're getting for fire implementation in the two respective parks. Our sampling techniques that we used, it was a multiple pronged approach where we use remote sensing, the MODIS satellite imaging to determine our fire regime analysis. The field data collection, we use the point-centered quadrant method, but we are using Winston Trollop's adapted method for the bush. We then use the disparture meter and the distance to tuft and look at species composition as well for the grasses. Small mammals, we put out Sherman traps in these various sites, as well as we had buckets to collect reptiles. And then for the Limpopo National Park, we ran structured community interviews and workshops with the community leaders and the surrounding areas. For this presentation, I'm going to really concentrate just on the fire regime characteristics for the two parks, because I was unable to put together the data for the biodiversity surveys, but also then to discuss some of the fire implications that we may have from the results that have come from this project. To characterize the fire regime elements in the different parks, we took MODIS imagery from 2003 to 2013, so we had 10 years of data. An burn algorithm, MCD 64 and 45 was run. Please do not ask me what that is, because I have no idea. But we have compared these algorithms to the Kruger National Park's fire data that we collect, and there was very good collaboration between the two. So I actually believe what the data has showed us. And then we calculated fire regime characteristics. We looked at the total area burnt, fire frequency, fire size, fire season, and then something FRP, fire radiative power. To go through each of them now, in terms of total area burnt, we've got area burnt here, the different years, and this is just the rainfall for the Kruger National Park. We saw that there was a quasi-biannual burn pattern for both parks, with the highest burns being experienced in 2004, 6, and 8. In Limpopo National Park, 1 year, 2004, which was a peak burned area for both parks, 350,000 hectares and 220,000 hectares for Kruger National Park. There is a relationship between we have shown previously for the Kruger National Park that there's a very strong relationship between the previous 2 years' rainfall and the area that burns. In terms of fire frequency, this is a map just depicting from green all the way to red, from 1 to about 9 to 10 years, in that 10-year period burning, the number of times that the area or the pixels have burnt. For the Kruger National Park, we see more frequent fires taking place on the basalt area rather than our granites. Just to let you know, we have basalts on our eastern boundary here, and on our western side we have the granites. And for the Limpopo National Park, the Wambia sandfell burns more frequently than the Lebombo North sandfell and the Mopani shrubfell. So this area here, which is a lot of red, is the Wambia sandfell burning. In terms of fire size, these are in hectares, the size of the fires that we looked at, and I just broke them onto what we're calling large, medium, and small fires. For the Kruger National Park, there wasn't any difference between the size of fires, but there were larger. Overall, between the two parks, we had larger fires being burnt in Kruger than Limpopo National Park. If you go specifically to the soil types, they were pretty much similar in the Kruger National Park. Limpopo National Park, the Wambia sandfell had much larger fires than the other two soil types. In terms of fire season, very briefly, we are dominated by late season fires, mostly in winter, and your early spring fires, which makes sense. Conditions in the two areas, grasses are dry and dormant in winter, and we have very hot weather conditions, so therefore this is very conducive for fires. So late season fires, very hot fires in both areas. In terms of fire radiative power, FRP, I would like to stress that this is not fire intensity. We are still trying to determine the link between FRP and fire intensity. And as an ecologist, I am more interested in fire intensity, but the data that we've got for MODIS satellite imagery is FRP, which some people say can be approximate, but for FRP, which is measured in megawatts. The Kruger National Park, the medium on both soils is very similar, but if you look at the circles on both sides, these are the extreme fire events that we've been having, much hotter on the basalts for Kruger. Limpopo National Park, we have lower fire intensity, fire radiative power on the Mopani shrub felt than on the Wambia sand felt. The third soil type, we could not get enough data to do the calculation. So overall, I would say we have hotter fires in the Kruger National Park compared to the Limpopo National Park. So in all, what does this mean? I always believe that we need to understand our history and therefore our what fire has been happening to determine what we can do and what we need to do in the future with fire. So what we're seeing in the Kruger National Park, we're having hotter, more frequent fires on our basalts, and therefore we would like to reduce this by changing our fire season that we are burning. The current fire policy for Kruger National Park is to reduce fire frequency and intensity on our basalts by trying to burn more fires early in the fire season by breaking up the fuel load. For our granites in the Kruger National Park, we state that if bush thickening is a concern, and therefore we would like to address this concern, we would like to have more frequent and hotter fires on our granites. But for this study, because it was north of the Olifants, we're not seeing that happening on our granite sections north of the Olifants. Bush thickening is really a concern in south, higher rainfall areas in the Kruger National Park. But as I say, the policy does say that if it is a concern, we would like to change the fire implementation plan for the Kruger National Park. Implications for Limpopo National Park. As mentioned previously, this is the first fire project that has taken place in the Limpopo National Park, and we would like to use this data to support the implementation and the development of a fire plan for the park. So one of the objectives for this project is to come up with a fire policy or plan for the park, and we are working with the fire managers in the park to develop an operational plan, not just one that will sit on the shelves. So we have completed the fire regime analysis, but the next step is to look at what the biodiversity outcomes are. And in order to look at that, we then selected sites of high and low fire frequency and in the various parks, and we looked at sites that had a high frequency that burned between 6 and 7 times in the 10 years. Our low frequency sites were more 1 or 2 times in the 10 years that we had the data for. In Kruger National Park, we looked at 2 soils, as I said, and we had 3 sites in them, and in Limpopo, the 3 soils were 3 sites. At each of these sites, we looked at the biodiversity elements. We had woody data, the grasses, small mammals, and reptiles. The data has been collected, we're still being processed. But that is the next step. We now know what the fire history has been, what we resulted and what we have. We now would like to look at the link between the fire implementation, the consequences of the resultant fire regimes, and therefore the biodiversity outcomes. And this will all feed into an implementation plan for the for the Limpopo National Park. So all I can say is watch the space. I'm sure I'll be back next year. Thank you.